I'm Tiasa, and Tying is my partner, and the two of us are working on this problem from the year 2000 on the AP exam. It says two runners, A and B, run on a straight racetrack for 0 is less than or equal to t is less than or equal to 10 seconds. The graph above, which consists of two line segments, shows the velocity in meters per second of runner A. The velocity in meters per second of runner B is given by the function v, defined by v of t equals 24t over 2t plus 3. So for the first part, for part A, we're just going to do part A and B. It says find the velocity of runner A and the velocity of runner B at time t equals 2 seconds. Indicate units of measure. So based off of the graph, we can say that one point on the graph is 0, 0. Another point on the graph is 3, 10. Then we can find the slope of this line, which runs through the x equals 2. By going rise 10 over run 3. So this equals m, the slope. Next, we can plug all these points into the point slope equation. So y minus 0 equals 10 over 3 times x minus 0. Now we just simplify that. So we get y equals 10 over 3 x. So in this problem, in the point slope equation, x is equivalent to t. And we're trying to solve for t equals 2. So you can just go y equals 10 over 3 times 2, which equals 20 over 3. And I'm going to calculate that. 20 divided by 3. And that is 6.667 meters per second. Okay, so finding the velocity of runner B at time equals 2 seconds is significantly easier than finding it for runner A because you have the equation. The equation again is v of t equals 24t over 2t plus 3, and you are solving for t equals 2 seconds. So you just plug in 2 to v of t. V of 2 equals 24 times 2 over 2 of 2 plus 3. You solve for that, you get 48 over 7. Plug it into your calculator. 48 divided by 7, and the answer is 6.857 meters per second for runner B. Okay, so for part B, we have to find the acceleration of runner A and the acceleration of runner B at time t equals 2 seconds, and we have to remember to indicate units of measure. So since we don't have an equation for runner A and we only have the graph, we're going to try to find the y-intercept of the point at x equals 2 on the derivative graph. So we know from class that the derivative of a point on a graph is going to be the x value, comma, the slope at that point. The slope at t equals 2 is 10 over 3. So all we need to do is divide 10 by 3, and that is our acceleration for runner A at t equals 2 seconds. So to find the acceleration of runner B at t equals 2 seconds, all we need to do is find the derivative of the velocity equation, because the derivative of a velocity equation equals the acceleration equation. So we need to use the quotient rule on this. So that would be 24 2t plus 3 minus 24t times 2 over 2t plus 3 squared. Now we need to find it at specifically t equals 2. So we'll plug in 2. And that equals and plug that into the calculator. 72 divided by 49, and you get 1.469 meters per second squared.